In this video, I'm going to show you how to solve systems of linear equations that have a ton of fractions in them. So I've got 3 examples in this, and just FYI, so I'm assuming in this video you already understand elimination and substitution. Those are techniques for solving systems. If you're not familiar with those, I would recommend maybe starting there and then coming back to this video, and I will drop links to both of my lessons on those techniques in the description. Okay, so let's just get the party started here. So starting with this first example, I'm really going to go into all the details with this first one. So I have this system here, and I've got a bunch of fractions. And so the idea of what to do for this, you don't want to just keep all the fractions, because that's just a headache, right? So instead, what we're going to do is a technique that we also use with just when we have fractions in general with an equation. We're going to clear them. So to clear the fractions, what you want to do is you want to find the LCD of all of the fractions in that particular equation. So looking in this first equation, what would the LCD be? I've got 1/6, 1/3, and 1/2. So the LCD of all those fractions would be 6. So this has an LCD of 6. And then for this other one, this one has an LCD of, well, 2/5, 3/5, and 6/5. This is just 5, right? They all have the same denominator, actually. So what we're going to do then is we're going to multiply all of the fractions by their respective LCD so that we can get rid of the fractions. So let me show you how to set that up. So I've got 6 times 1 over 6x minus 6 times 1/3 y equals 6 times 1/2. And then let's set up the other one. So I'll have 5 times 2/5 x minus 5 times 3 over 5 y, and then 5 times negative 6 over 5. Okay, so now that we've set this up, we can start to clear out the fractions. And so I'll kind of walk you through how do you actually do that. Okay, so what you'll notice is that each denominator divides into that number that we're multiplying by. So 6 divides into 6 how many times? Once. So I'm going to write this out. This now becomes 1 times 1x. So 1 times 1x is just x. Okay, so let's keep going. So now I've got 6 times 1/3. 3 goes into 6 how many times? 2 times. So this is 2 times 1y. So this altogether is going to give me negative 2y. So let me write that down. Minus 2y. And then for the last one, 2 goes into 6 3 times. So I'll note that. And so that leaves me with 3 times 1, so that's just going to be 3. Okay. So we got the first equation done, and now we can move on to the next one. So for this one, this was actually going to be a lot simpler because 5 goes into 5 just once every single time. So really what ends up happening in this case is just like the denominators just kind of drop out. So if you look at this, so I'm left with like 1 times 2x. This is going to leave me with 2x. And then here, moving on to the next one, so these 5s drop out, and I'm left with minus 3y. And then for this last one, these 5s cancel out, so I'm just left with the negative 6. And so now, I know it took a little bit of work, but this is what we're left with, and I would much rather work with these equations than the original set of equations. So now we can pivot and finish this. So let me clear some space. Okay, so here's what I'm left with. This x minus 2y equals 3, and 2x minus 3y equals negative 6. So from here, once you get to this point, you can do anything you want to solve the system. So notice if you wanted to use substitution, you could pretty easily solve for this x here, and you could use substitution, or you can use elimination. And you can use elimination by, you could multiply this line here by -2. So any technique goes now. You're almost done. So what I'm going to do is elimination. I like that technique a little bit better, I guess. So I'm going to multiply this by -2, this whole equation. So in doing this, I get -2x plus 4y equals -6, and 2x minus 3y equals -6. So now if I eliminate, I can just add straight down and I get y equals -12. Okay, and so now you might be thinking, well, where do I plug that back in? So you can plug that into these nice equations. You don't have to plug the -12 back into the original one. You can just plug it back into those nice equations that you found, and you can really just work with these equations going forward. So if I do this, I get x minus, I'm going to plug -12 into the first equation, and then I'll go ahead and solve for x. So I get x plus 24 equals 3. Subtract the 24 from both sides, and I get x equals -21. So my solution here is -21, -12. And so that would be it. Okay, so let's move on to the next problem here. So same idea. So -1/2 x minus 3/4 y equals 1, and then 1/3 x plus 3/2 y equals 2/3. So let's kind of break this one down. So starting with the first equations, what would the LCD of the fractions that you see here, what would that be? Well, the LCD here would be 4. And then for the other equation, so 1/3, 3/2, -2/3, the LCD here would be 6. So where we want to start is we want to set this up. So maybe go ahead and set up the multiplication and see if you can do the cancellations, and then hit play when you're ready. So I'm going to go ahead and set up these equations so that we can go ahead and do the cancellations. So I'll just kind of run through that. Now, one thing that I want to point out here in setting this up, you have to multiply every single term or every single part of your equation by 4. So including this one also has to be multiplied. Otherwise, you're going to throw off the whole balance of the equation. You can't multiply just the fractions. Think about it. An equation is like a balancing act. So if you only multiplied these two parts by 4 but not this, then you're going to lose the whole balance of that equation. So here's the setup for this first one, and now let me show the other one. Okay, so now I've got everything set up and we can kind of move forward with this. So once again, you always think about dividing the denominator into that LCD. This LCD is a strategic choice that will definitely cancel out all your fractions. So 2 goes into 4 how many times? Goes in twice. So if I just look at what I'm left with, this is 2 times -1x, so this leaves me with -2x. Okay. So now 4 goes into 4 once. So 4 goes into 4 once. So I'm left with 1 times 3y. So this is just going to leave me with this, don't forget the minus sign right here. So this is going to be minus 3y. And then in the end, I don't have to do any cancellations here. Just 4 times 1 is going to be equal to 4. Okay, so now let's go to the other equation. So 3 goes into 6 2 times, and 2 times 1x will leave me with 2x. And then 2 goes into 6 3 times, and this is going to leave me with 3 times 3y, which is 9y. Oops, and this should be minus, nope, this should actually be plus. Sorry, I messed up the symbol here. This should be plus 9y, sorry, continuing from the symbol up here. And then finally, 3 goes into 6 twice. So 2 times -2 is -4. And so now we've got everything set up. So let me go ahead and clear some space. So in this particular problem, this one's really all set up for elimination, right? So I've got -2x and 2x. So, I mean, we really should just eliminate. So I can go ahead and just do that right away. So this is going to give me 6y equals 0. And if I divide both sides by 6, I get just y equals 0. Now I can plug that 0 back into one of these equations. I don't have to go back to the originals. So if I plug that in, I'll plug it into the first equation. So I get -2x minus 3 times 0 equals 4. So this will give me -2x equals 4. I can divide both sides by -2 to get x equals -2. So my solution is -2, 0. Okay, so we have one more example, and I highly recommend, actually, if you feel like you've kind of got this, that maybe you pause and just try this example on your own and then hit play. So to begin, so first we want to find our LCDs. So in this case, the first equation, my LCD here is going to be 10. And then with this other one, 1/4 x minus 1/2 y equals -9, the LCD here is going to be 4. So once again, you'll want to set this up and do your cancellations and all that good stuff. So I'll go ahead and start that. So okay, so notice I've got everything set up here, and I multiplied even these non-fractions by those numbers, so very important that you did that. So now as we work on cancellations, so the 2 will go into the 10 5 times, and so I'm left with 5 times 1x, which is 5x. And then moving on, so I've got the 5 goes into the 10 2 times. 2 times 3y is going to give me 6y, and then 10 times 6 is 60. Okay, so moving on to the other equation, so 4 goes into 4 once, so I'm left with 1 times 1x, which is just going to be x. And then 2 goes into 4 twice, so this is 2 times 1y, so this will be minus 2y. And then 4 times -9 is -36. Okay, cool. So let me go ahead and just make some space. And so once again, let's see, I'm going to use elimination one more time. Like I said, I think it's a little faster. So I have these two equations. I think it would be easiest if I multiplied this particular equation by 3. I could have also multiplied it by 5, so there's always like more than one way, or not always, but there's often more than one way you can do things. But I'm going to multiply this by 3. So restating my system, now I have 5x plus 6y equals 60, and 3x minus 6y equals -108. Okay, so now I can go ahead and eliminate. So I'm going to get 8x equals -48. And then I can divide both sides by 8 to get that x equals -6. So we can now plug this back into one of the other equations. So let's see, I'll plug this into the second equation. So I get 6 minus 2y equals -36. Subtract off the 6's to get -2y equals -42. Divide both sides by -2 to get y equals +21. So my solution here is going to be -6, +21. And so that is how you can clear out your fractions so that you can still solve systems, and then you could just use whatever techniques you want. Okay guys, I hope that was helpful. Thanks for watching. I'll catch you next time.